afternoon, students. In previous classes, we have discussed about the detailed mechanism of SN1 and SN2 reaction. So finally, today we are focusing on the summary of SN1 and SN2 reactions, and after that we are discussing the free radical substitution reaction. It's a major summary of SN1 and SN2 reaction. Factors: SN1, SN2, the nature of substrate. Hindered alkyl halide prefers SN1 mechanism because hindered alkyl halide form more stable carbocations. So the rate of reactions of alkyl halide is 3 degree, 2 degree, 1 degree methyl halide. While in the case of SN2 reaction, unhindered alkyl halide prefers the SN2 mechanism. The order just reversed from the SN1 mechanism. The concentration and strength of nucleophile. In SN1 reaction, there is no importance of the concentration and strength of nucleophile because in rate determining step there is no role of nucleophile, while in the case of SN2, higher the concentration of and stronger the nucleophile, higher will be the rate of reaction. Solvent. In SN1 reaction, prefer polar protic solvents, especially water. In the case of SN2 reaction, prefer polar aprotic solvents like acetone, DMSO, DMF, etc. And finally, the nature of leaving group. In the both cases, better leaving group are favorable for both type of reactions. Generally, weaker bases are better leaving group. For example, I- is a best leaving group than bromide. Bromide is better leaving group than chloride, and chloride is better leaving group than fluoride. Now we are discussing about the next type of substitution reaction, which is called free radical substitution reaction. One of the important category of reactions has mechanisms that involve homolysis of covalent bonds with the production of intermediates possessing the unpaired electrons called radical. Like it is a AB, it is a covalent compound. There is a homolytic cleavage in the formation of A dot and B dot. This dot showing the unpaired electron, which is called free radical. Almost all small radicals are short-lived, highly reactive species. When they collide with other molecules, they tend to react in a way that leads to pairing of their unpaired electrons. Generally, hydrogen abstraction is one of the important features in radical reactions. Now, took up the example of halogenation of alkenes. Alkenes are non-polar, and most of the reactions are a result of homolysis in alkenes. Methane, ethane, and other alkanes react with halogens by free radical mechanism. The general reaction is given by RH, which is presented for alkane, presentation of alkane. X2 halogen gives RX, alkyl halides, and HX. Here X2 stands for the halogen. The reactivity of halogens for given alkane is fluorine, chlorine, bromine, and iodine. And the reactivity of hydrogen is 3 degree, 2 degree, 1 degree, and CS3H. We are taking the example of monochlorination of methane for explaining the free radical substitution reaction. Generally, multiple halogenation takes place in alkane. Means these all hydrogens are substituted by halogen or any other substance. For the mechanistic point of view, we will consider only halogenation here, which is monohalogenation. Monohalogenation carried out when alkane taken in excess amount than halogen. The general reaction of methane is given by methane react with chlorine in the presence of sunlight gives methyl chloride plus HCl. Here the interesting point is noted that the small amount of ethane is also formed. The above reaction takes place by free radical substitution reaction, which is also called chain reaction. It is carried out by following 3 steps. The first step is called chain initiation step. In the case of chlorine, react in the presence of sunlight gives Cl dot. The enthalpy change in this reaction is plus 243, means the reaction is endothermic. Chain propagation step. In the case of this step, methane react with chlorine radical, which is formed in first step, and form alkyl radical, here methyl radical and HCl. The enthalpy change is plus 8 kJ per mole, means the reaction is again endothermic. Now the alkyl radical react with the halogen, fresh molecule of halogen, and gives the alkyl halide, here methyl chloride plus halogen free radical. Enthalpy change is minus 109. This step is called propagation step because here halogen radical is consumed, while here it is again produced. The reaction is propagated in this manner. The net enthalpy change in this reaction is minus 101 kilojoule per mole. The reactions of these steps shows the overall reaction. So the overall enthalpy of reaction is considered as minus 101 kilojoule per mole. Now finally, chain terminating step. It is a possibility of the collision of these radicals and form methyl halide. Also, there is a possibility of collision of these two alkyl radicals and form the alkane. Here is a methane, here is a ethane, and also there is a possibility of collision of these two radicals and formation of halogen. It is clear that in this step, ethane is also formed in some amount.